Let me introduce Alexandra Jamieson. She will speak about cardiopulmonary fitness and changes in tissue saturation index during exercise in people living with long COVID compared with controls.
Thank you so much. I'm really delighted to be able to present this work to you all today. So long COVID can be defined as signs and symptoms that develop during or after an acute COVID-19 infection that continue for more than 12 weeks and aren't explained by an alternative diagnosis. And symptoms are very wide-ranging, with over 200 that have been reported, and these are across all bodily systems and can present in those with very mild, even asymptomatic acute infections, all the way through to those who required hospitalization. And these symptoms have been reported in 2 million individuals in the UK alone, and they can persist for many months or even years with a periodic and relapsing nature to them. And so I think this really highlights the importance of research into what mechanisms might underlie these symptoms. And the symptoms that we've been really interested in are that of exercise intolerance and persistent fatigue. And exercise intolerance can be defined as the diminished capacity to perform exercise due to a decreased ability of the pulmonary and cardiovascular systems to supply oxygen to the body, a decreased ability of the musculoskeletal system to effectively use that oxygen, or both. And we can then assess the integrated response of these bodily systems and someone's capacity to exercise using designated tests. And we do so using semi-recumbent cycle ergometry and cardiopulmonary exercise testing in our clinic. And in addition to the traditional measurements taken throughout CPET, we also fit individuals with a Portamon device, cover that with a neoprene sleeve, and the participants wear that during the baseline resting phase, throughout exercise, and also into recovery, so that we can get that measure of TSI. And so here's an example of one of our traces from a participant that was involved in the study. And the key measurement parameters that we currently look at are that of the baseline during that resting phase, the maximum TSI during exercise, the minimum TSI, and from that we then derive the change in TSI, with a greater drop during exercise thought to represent a failure of oxygen supply to keep up with the demand of the contracting muscle. And we've applied these techniques in 2 long COVID studies, the first of which, the Mexico study, was a clinical cohort, of 32 long COVID cases. These were individuals who'd been referred from their GPs into the UCLH long COVID clinic due to the severity of their symptoms. We then invited individuals into our clinic and did a whole host of assessments looking at the autonomic nervous system, lungs, heart, micro and macro vasculature, and skeletal muscle. And along with the submaximal CPET testing and the assessment of TSI during exercise, we also did measurements of oxidative capacity and post-occlusive reactive hyperemia in both long COVID individuals and controls. These individuals were on average in their 40s and predominantly female. Our results from this study showed a marked reduction in exercise performance in the long COVID cases compared to the controls. Interestingly, we didn't observe differences in the drop in TSI during exercise, but we did observe reduced oxidative capacity in those with long COVID compared to controls, as demonstrated by the prolonged time constants. Now, in the interest of time, I focused on the mNIRS results here. However, it is worth noting that in these individuals, we did observe autonomic nervous system dysregulation in a significant proportion. And so our conclusions from that study were that these multi-system factors might contribute to the impaired exercise tolerance in long COVID individuals. And then we were really keen to extend this analysis into more of a population-wide based study in which they had much milder incidence of long COVID. And we did so by performing a sub-analysis using data from the convalescent study. And this study recruited from 2 pre-existing observational-based population studies, the Twins UK and ALSPAC, the study that Shana mentioned earlier today. And our sub-analyses in this study only considered the long COVID individuals who reported persistent fatigue, of which there were 31 cases and 111 controls. And these participants were slightly older than the Mexico individuals on average, but again, predominantly women. And in line with our findings in the Mexico study, we also observed reduced exercise performance in these long COVID individuals compared to controls. Unfortunately, as the study aims of convalescence were much broader than Mexico, we weren't able to get the oxidative capacity measure, but we did have TSI during exercise. We observed a drop in TSI during exercise, which was more than double in long COVID cases compared to controls, which may indicate that a failure of oxygen supply to keep up with demand could contribute to the persistent fatigue experienced by this group of individuals. However, it's very important to note that based on the p-value for that finding, this could just be a chance finding. And so our overall conclusions then are that long COVID with persistent fatigue is associated with reduced exercise performance and aerobic fitness, and that mNIRS is a really useful tool that can provide insight into the mechanisms that might underlie these symptoms. And so that just leaves me to thank everyone that was involved in collecting the data, both past and present members of staff, and particularly to the study participants who so willingly gave up their time when they felt so poorly. So thank you.
Yeah, thanks for the presentation. Are there any questions? No, oh yeah, sorry.
Thanks very much.
Yes.
You're just looking at that with the pulse BMI is higher, the heart and just wondering, are these kind of metabolic you think that kind of result, or would you
I think it's very difficult to say with the analysis I've got sort of in front of me now. I mean, just to say that the potential outcome means analysis we did our best to sort of condition on BMI. So we kind of took an approach as much as we could. I think what will be really interesting with this study is that, as Shana alluded to earlier, is that we have data on these individuals throughout the life course. So that's the next step really, is to be able to say what happened prior to the infection, which in the Mexico study and other studies alike, it's just very difficult to pinpoint, you know, what had happened prior and then post infection. And like you say, to try and disentangle that question. Yeah.
Yeah, thanks. I have a follow-up question on that. How long was the patients tested after the infection? And do you think is a disuse the conditioning, or is really related to the disease?
So it was on average 14 months post-infection. I think, again, it's sort of a similar answer. It's really difficult to say with those individuals because we just captured at that one time point. And I know there's arguments for and against in the literature. But I think it is pointing towards a signal. I know, thankfully, it really, you know, agreed with the work that your team had done as well, that there is something going on in the muscle, and whether that's related to deconditioning or direct effect on the mitochondria that then results in people not being able to exercise because they're so fatigued, which then leads to deconditioning. It's really difficult to say what came first, I think, with this kind of data.
Yeah, so that's...
When you tested them, you asked if they were feeling better or worse?
We didn't ask that specific question. They were definitely still symptomatic on the day of the visit, but at the time of the study design, that kind of idea of the post-exertional malaise and that symptom in particular wasn't something that we were all aware of, but actually the participants made us aware that in some cases, even just coming to clinic they felt then put them into that kind of relapsing state. But it's not a specific question we asked of, are you in a relapse, or, you know, is this kind of a persistent state that you're in at the moment?
Yeah, first one, then we have.
Do you evaluate the experimental pattern, like restrictive or restrictive?
Oh, in the spirometry, yes. So we did have a third of individuals who had also sort of abnormal, as it were, spirometry patterns. I can't remember off the top of my head which direction that was. The clinicians involved sort of said in isolation they wouldn't think that that would be responsible for the exercise performance reductions we observed. But again, it was sort of tying into this idea that possibly those sort of just subclinical thresholds in multi-domains could then explain that reduction in performance.
Last question.
So mild, yes. So these, in the Mexico study, 30 of those individuals were community managed, very mild. 2 had been hospitalized. We did sensitivity analysis removing those 2, and the results were the same. And then the convalescent study, that is all mild acute infections.
Besides very careful.
Mm-hmm. Yes, we completely agree. And deconditioning isn't something we can rule out in those individuals. But yeah, I agree, it's difficult to say.
Yeah, thanks so much.
Thank
we need
you.
to go.